From the College of Business and Economics at Boise State University, this is Biz MBA 550. My name is Regis Turpin, and the topic of this video is other inventory management models. In my previous video, I introduced several techniques to manage inventory. The first one was the ABC classification. The second one was the basic EOQ model. And then we looked at the more advanced version of the EOQ. This is the EOQ with quantity discounts. Now in this video, I'm going to introduce a few other models that I use to manage inventory. So the first one that I want to introduce is a probabilistic model. So in the model that we have seen before, we assumed that demand was known and constant and therefore was very predictable. In a probabilistic demand model, instead, we're going to assume that there is variation in the demand. That's what we see here. Now, in a previous model that we saw, we assumed that that demand was certain, and therefore we assumed that what happens after the reorder point is reached is that demand is going to continue to go down at the same pace. But that's going to change when we have a probabilistic demand. Instead, several scenarios could happen based on how fast the demand is going to go. The first scenario is the most likely scenario, is simply to assume that demand is going to go down at the same pace as the previous demand, meaning the demand before you reach the reorder point. That would be the middle case. If that happens, basically you are right in the middle of the distribution, and therefore you have 50% chance of having too much demand once you're done with that term, or you have 50% chance of having not enough inventory, in which case you're going to get what we call a stock out. So that's a 50-50. That's in the middle of the distribution. Now, there's a couple of other things that could happen. Of course, the first one would be that right after that reorder point, demand starts to slow down. That's what is illustrated here is that demand is slowing down. So if that happens, you see that at the end of the lead time, so when you receive the shipment from the supplier, then you're going to have still some unit left in your inventory. Now, what could also happen is that after the reorder point is reached, that demand suddenly accelerates, in which case you would be running out of inventory faster. If that happens and you don't have any safety stock, you're going to run out of inventory before you receive your shipment. But what most company would do to avoid that problem is to add some safety stock just to be on the safe side and avoid any stock outs. So that's what I want to describe now is the methodology to do that and determine how much safety stock do we need to have based on the level of risk the company is willing to take. So let's take an example where we have a demand that is 4 units per day and we have a lead time of 3 days. So it takes 3 days to receive a new shipment of those items. And the standard deviation of demand during lead time is 1. So the first case we're going to talk about is when we are in the middle of that distribution. So we assume that demand is just going to follow the average demand before the reorder point. So if that happens, so the reorder point will be calculated as the demand during that lead time. So that would be 4 units per day multiplied by 3 days. That's 12 units. So that would be now if we start reordering items when you are at 12 units, then what will happen is that you're going to have a 50% chance of stock out or a 50% chance that you're going to have too many items. Now, for most company, a 50% chance stock out is unacceptable. So what we'd like to talk about now is what if, for instance, a company wants a 95% chance coverage, meaning they are not willing to take more than a 5% chance that they're going to run out of a material, that they're going to have a stock out situation. So that's what it would look like instead. So that's the risk of stock out here. They want that limited to 5%. So how do we figure out how much safety stock we need to add on top of the normal inventory that we would have on the 50% case scenario? Well, the way we do that is the reorder quantity is still going to be the demand during lead time, but we're going to add that safety stock, and the safety stock is calculated as a z-score multiplied by the standard deviation of the demand during lead time. So how do we do that in practice now? So we had almost all the information we need if you look at the equation. So demand during lead time is 3 times 4, that's 12. That's the 12 we had before. We have the standard deviation of demand during lead time, which is 1. So the only piece of information that is missing here to calculate how much inventory we need is the z-score. So the z-score, I remind you, is the number of standard deviation away from the center that we are, okay? So how do we figure that out? It's going to be based on a table. So if you look in any statistics textbook, you're going to find this table. And that table is designed to translate a probability into a z-score or vice versa. So in this example, we're going to go from a probability to a z-score. So we want a 95% coverage, and 95% will be from the very left of that distribution all the way to that z-score here. Now you see that this particular table goes only from the middle to the z-score, so it omits 50% if you like. So what we want to look for in that table is not 95%, but 95% minus those 50% here, so it's only 45% here. So 0.45 if you like. So let's look at the number in that table and let's identify the one that is the closest to that 45%. So you see that here I'm at 44.52, 44.74, 44.84, 44.95, 45.05. That's the one we're going to select here. So that's this number here. Once we identified that probability, we're going to look at the number at the top of that column and also the number on the side here. And we're going to add up those two numbers. So 1.6 here plus 0.05, that's 1.65. That's my z-score. What does that mean? It means that if you want to have only a 5% chance stock out, then your z-score is 1.65, or if you like, the cutout is 1.65 standard deviation away from the center of that distribution. So now that we have the z-score, all we have to do is to fit it in our equation, and that would be 3 times 4, that's 12, plus 1.65 times 1, that's the standard deviation. So you would have to have 13.65 units of inventory in order to have only a 5% chance stock out. Now, what you would have to do is to round it, of course, to 14, because if you rounded it down, then of course it would annihilate some of that safety that you added, and it wouldn't make sense. So to be on the safe side here, we're going to be more conservative. We're going to round it up to 14 units. So that's how we calculate safety stock. Let's talk about a couple of other models. The first one is called the economic production quantity, and this one looks a lot like the EOQ quantity with a key difference. The main difference between the EPQ and the EOQ model is that in the EOQ model, if you remember, we were receiving all the items at once. But the EPQ model relaxes this assumption. Instead, we can assume that we are starting processing units as we receive them. We don't have to wait for the entire shipment to be ready. So let me show you with a diagram how that works. So you see that if you remember in the EOQ model, when we receive everything was received at once, so that line here was vertical. Now you see that for the EPQ, it's different this time. What it shows is that, for instance, if you are workstation B and you're receiving items from workstation A and that workstation is right next to your workstation, what would happen is that you could start processing those items in your equipment and you don't have to wait for the entire shipment to be received at once before you do that. So as soon as the next workstation A is making those items, you can go and tap into it and one by one, and that's what is illustrated here. So if that's the production rate of workstation A and your workstation B, as long as they produce faster than you produce, then you're going to be fine. You can start processing it right after the first unit is completed. By the way, this model also work for a retailer. So if a retailer is selling items but also manufacturing them, same thing, they can start selling those units as soon as they are being produced by their facility. Last model is called a fixed period model. It's different model which assumes this time that what we are looking for is not so much to identify the number of units we need to order over and over, but instead what we are doing is we're going to order on a regular basis. And the question is, how much quantity do we need to order in order to be back to a certain level of inventory that we determine was the correct level of inventory. So again, a picture speaks better than words. So this is what it looks like. So let's imagine you're a small company, for instance, and you have a small convenience store, for instance, and you reorder every Friday. So the way the fixed period model would work is that every Friday you're going to go into your inventory and you're going to count how many units you have left. And then you're going to reorder just enough of what is necessary to take it back to what you determine was the ideal target maximum for a Monday. Okay, so let's say you determine that you wanted 100 unit on Monday and you're left with 10 units on Friday. So you're going to reorder 90 units to get back to that 100 unit target. Then at the end of the following week, you do the same thing. So let's say you determine you've used up 30 and there are 70 left. Then you're going to reorder 30 to get back to that target maximum of 100, etc., etc. Now, what is visible, perhaps you've noticed that, is that demand varies from time period to time period. So you see, for instance, that for this time period here, demand is kind of slow, while at the next time period, the demand is pretty fast. And in fact, we're almost running out of items here before the end of the time period. So that's one of the feature of the fixed period model is that it allows for stock outs, which was impossible with the original EOQ model. So let me illustrate that. So you see in this second example here, in my second time period here, demand is so fast that I'm running out of item before it's time to reorder. So if that happens, what I would do is not only I would order the entire quantity from zero, but I'm also going to add a few units for the customers who are willing to wait for those extra units. The customer that came in our store and we turned away and asked them to wait. If they are willing to wait, then you would have to add that to the total. So in the fixed period model, here is the equation. Basically, the quantity you're going to order is going to be the target, that's the number that you want at the beginning of the period, minus how much on-hand inventory you still have left at the end of the period. And you're going to subtract earlier order that you haven't received yet. So sometimes you reorder items and they don't show up right away, so they may show up 2 or 3 times further down the road. So if you did order them, you're not going to count them again. So that's what this means. And finally, we're going to add for possible back orders. So let's say you have 3 people who ordered the jacket and you told them you didn't have any and they are willing to wait for them. So not only you're going to order those 50, but you're going to add 3 jackets on top of that, and that would be your total. This concludes the presentation on inventory management and the videos for week 4.